Good day, everyone, especially to our linear algebra instructor, Dr. Jessa A. Clutin. By the way, I'm M&M Lumolho, and I'm going to present the Kirchhoff's laws. Systems of linear equations is also used in electrical network. Analysis of electrical network is guided by two properties known as Kirchhoff's laws. The first property is all the current flowing into a junction must flow out of it. The second property is the sum of the products IR. I stands for current and R stands for resistance around a closed path is equal to the total voltage. It means that voltage is equal to I times R, or current times resistance. A battery is denoted by this symbol and the resistance is denoted by this symbol. Let's consider the electrical circuit. This is the image of the network. So what we're gonna do, let's analyze this. And let's apply the properties of the Kirchhoff. So let's get the junction 1 equation. Since the current 1 and current 3 is moving towards the junction 1, so the equation would be G sub 1 I sub 1 plus I sub 3 is equal to I sub 2 because I sub 2 is moving away from junction 1. As what you have noticed that the junction 2 is just only the same of the equation of the junction 1 because the current 2 is moving towards from to junction 2 and the current 1 and current 3 is moving away from junction 2. So it's just only the same from junction 1. And let's also get the equation number 2 from this network image. Okay, so this is the symbol of the battery, right? So based on the arrow from current 1 and the current 2 moving towards to this first battery, that would be I sub 1 or R sub 1 times R sub 1 plus R sub 2 times R times I sub 2 is equal to how many voltage of the first battery? There are 3 voltage. Okay. Next is we will get the equation 3. So this is our equation 1. So let's get the equation 2. This is our second battery, right? And the current 3 and current 2 is moving towards to the second battery. So R sub 2 times I sub 2 plus R sub 3 times I sub 3 is equal to how many voltage of the second battery? 1 voltage. And this is our second equation. The third equation rather. Second equation and third equation. So let's use the Kirchhoff law to determine I sub 1, I sub 2, and I sub 3. And based on what we did earlier is that we get the equation 1, we get the equation 2, as well as the equation 3. And this is our formulated equation based on the image given, or the given image rather. Okay, so what we're gonna do right now is that we will get the augmented matrix. Then the network system is given by this from equation 1 from equation 3. And the next step that we're gonna do is to get the augmented matrix. And when we say augmented matrix, it's just we only get the coefficient. This is the coefficient of the equation 1 because I sub 1 is the coefficient of it is 1, then negative I sub 2 is negative 1, and I sub 3 is 1, and the equal value of the equation 1 is 0. We write 0. Likewise from the equation 2 and equation 3. Now, we reduce this matrix to row echelon form. So when we say row echelon form, is that we need to get the staircase like this. Okay, that would be, it should be equal to 0, 0, and 0. And like this, our goal is to make this a leading coefficient of 1. But our first goal is to make the 4 into 0. That's why we have this elementary row operation. Negative 4 row sub 1 plus row sub 2 to produce new row 2. And if we apply that elementary row operation, we get this new row 2. That is 0, 7, negative 4, and 3. And our next goal is to make the 7 into 1 because when we say leading coefficient, that should be equal to 1, right? So let's multiply the second row by 1, 7. So 1, 7, row 2 to produce new row 2. And our new row 2 is 1, negative 4, 7, and 3, 7. And our next goal is to make this 3, or shall I say the A3 sub A32 into 0. That's why our elementary row operation is negative 3 row 2 plus row 3 to produce new row 3. That's why if we apply this elementary row operation, we have this new row 3. 0, 0, 19 over 7, and negative 2 over 7. And next is we need to make this 19 over 7 into 1. That's why we multiply the third row by 7 over 19 because 7 times 19, that would be 19 times 7. That would be, so 9 times 7 is equal to 63. So 3 carry 6, that would be 13. So 133, right? So 133 over 133, that is equal to 1, right? Because they have the same value of the numerator and denominator. That would be equal to 1. And we multiply the 7 over 19 to negative 2, 7. As a result, this is our new row 3. 0, 0, 1, negative 2, 19. And our new elementary row operation is row 1 plus row 2 to produce new row 1. Because our goal is to make this into 0 because we need to reduce it to Gauss-Jordan form. So if we add the row 1 plus row 2, our new row 1 is 103737. And our next goal is to make the 37 into 0. That's why negative 37 row 3 plus row 1 to produce new row 1. As a result, our new row 1 is 100919. That's why our next goal is to make this into 0, this negative 47. In order to make this into 0, we use this elementary row operation, which is 4, 7 times row 3 plus row 2 to produce new row 2. And if we apply that elementary row operation, so our new row 2 is 0, 1, 0, 9, 17. The corresponding linear system is given by I sub 1 equals 9 over 19, I sub 2, 7, 19, I sub 3 is equal to negative 2, 19. Let me read my assigned item number that I need to answer. Number 72, network analysis. Determine the currents I sub 1, I sub 2, and I sub 3 for the electrical network shown in the figure. And let's use the Kirchhoff law to determine the I sub 1, I sub 2, and I sub 3. This is our junction 1 and junction 2, right? Okay, so let's observe what's the direction of the arrow of the I sub 1 and I sub 2, and also the I sub 3. For the junction 1, so let's write the junction 1. The I sub 1 and I sub 3 have the same direction moving towards to the junction 1. That's why we write I sub 1 plus I sub 3. And only the I sub 2 has its own different direction, which is moving away from junction 1. That's why that is equal to I sub 2. This is our first equation. The junction 2 has the same equation. Why? Because I sub 1 and I sub 3 is moving away from junction 2, and only the current 2 is moving towards to junction 2. That's why they have the same equation only. Um, from this equation, we need to get the equation 2, right? Because junction 1 and junction 2 has only the same equation, so we need to just convert it into 1. So equation 2, we need to observe how many batteries are. There are two batteries, right? Because 3 voltage and 2 voltage. And to get the equation of the voltage, or shall I say, the battery, is we need to observe also the direction. Since the direction of the I sub 1 and I sub 3 is moving towards to the first battery, as a result, I sub 1 R sub 1 should be times 2 I sub 1, because that's of getting the voltage. Voltage equals R times I plus R sub 2 times I sub 2 is equal to how many voltage? 3 voltage. And we need to get also the equation 3. So let's observe the direction. I sub 3 and I sub 2 is moving towards to the second battery. So it means R sub 2 times I sub 2 plus R sub 3 times R sub 3 is equal to how many voltage? 2 voltage. And we need to substitute the resistance because R sub 1 is equal to 3 ohms. So we need to substitute this and this. So 3 ohms, we need to substitute it into 3, and R sub 2 is 4 ohms. That would be 4. And R sub 3, substitute it into 2. As a result, this is our equation. Equation 1, equation 2, and equation 3. The network is given by I sub 1 minus I sub 2 plus I sub 3 equals 0. 3 I sub 1 plus 4 I sub 2 equals 3. 4 I sub 2 plus 2 I sub 3 equals 2. Why is it that it makes it negative I sub 2? Because we need to transpose it, and if we transpose it, the sign will be changed. That would be negative 2, and the equal value of this is 0. And we need to get the augmented matrix. And when we say augmented matrix, is we just only get the coefficient of our formulated equation based on the given figure. So 1, negative 3, 1, 0, 3, 4, 0, 3, then 0, 4, 2, 2. And now we reduce this matrix to row echelon form. To do this, first multiply negative 3 from first row and add the result to the second row. So this is our elementary row operation. To get the new row 2. So if we apply that, because negative 3 times 1, that's plus 3, that would be negative 3 plus 3 equal to 0. Because they have the same value but different signs, so the sum would be equal to 0. So that's why 0, 7, negative 3, 3. This is our new row 2. And our next goal is to make this a leading coefficient, 1. Okay, that's why we multiply the second row by 1, 7. If we apply this elementary row operation, that would be 1, negative 3, 7, 3, 7. That's our new row. Oh, very good. And our next goal is to make the to make this into 0, because we need to get the staircase. So this is our elementary row operation, negative 4 row 2 plus row 3 to produce new row 3. Because we need to multiply the negative 4 from second row and add the result to the third row. That's why our new row 3 is 0, 0, 26 over 7, 2, 7. As what you have noticed is that is 26 over 7, right? And we need to get the leading coefficient of it. That's why we need to multiply that by 2 by 726. Because if they have the same value of the numerator and denominator, the quotient would be equal to 1. Because 26 times 7 is 2 carry 4, that is 14 plus 4 is 182. So 182 divided by 182, so the quotient is 1. Very good. So this is our new row 3. 0, 0, 26, 0, 0, 1, 1 over 13. Okay? Let's add the first row and second row, because we need to proceed to the Gaussian form. Gauss-Jordan form rather. And we need to make this into 0. That's why we need to add the first row and second row. So row 1 plus row 2 to produce new row 1. And if we apply this elementary row operation, our new row, as a result, this is our new row 1, 1, 0, 4, 7, 3, 7. Our next target is to make this 4, 7 into 0. Our elementary row operation that we use to make this 0 is negative 4, 7 times row 3 plus row 1 to produce new row 1. If we substitute the given value of the row 3 and row 1, they have the same value but different signs. And the rule says that the sum is equal to 0. That's why our new row 1 is 100,513. And our last target is to make the negative 37 into 0. That's why our new elementary row operation that we use is negative 37 atong i-times sa row 3 mo na itong row 3 plus row 2 to produce new row 2. Likewise, gihapon sa itong previous nga elementary operation, they have the same value but different signs, and the rule says that the sum is equal to 0. Our new row 2 is 0, 1, 0, 6, 13. And this is our Gauss-Jordan form because they have a 0 above the leading coefficient of 1, and we have also a 0 below the leading coefficient of 1. That's why we get the value of the respective current. The current 1 is 513, the current 2 is 613, the current 3 is equal to 113. Therefore, to determine the current of the three currents based on the question that we need to answer, the current 1 is equal to 513, the current 2 is equal to 613, and the current 3 is 113. And by that, may God be praised, and thank you very much.